The Fish Passage Extension and the Dendritic Connectivity Index is a river network analysis toolset for visualizing river networks and performing barrier impact assessments on river connectivity. Both FIPEX and the DCI have open source code available on request from the developers, and further information can be found on the GitHub link below. Habitat connectivity within river networks has been found to be crucial for the persistence of migrating fish populations. This has led river ecology research into taking a holistic network approach when studying how barriers impact fish migration and populations. FIPEX, when used with the DCI, offers a toolset for users to model river networks and apply connectivity metrics to real-life ecosystems to assist in resource management and conservation efforts of migrating fish species. This toolset can be applied to a variety of fields, including network planning for road construction to ensure the impacts of small barriers on river connectivity are minimized. The DCI and FIPEX can also be used in environmental impact assessments for larger barriers such as hydroelectric dams to optimize project resources and inform barrier placement within the river network. FIPEX and the DCI can also be used in river networks with pre-existing barriers, and the toolset can aid in habitat restoration projects, including constructing fish ladders, improving barrier infrastructure, or barrier removal. I will now differentiate between FIPEX and the DCI, but what they offer and what interface the tools can be used on. The Fish Passage Extension is an add-in to the Esri Geographic Information System software that visualizes the river network and summarizes habitat quantity. FIPEX allows users to configure the river network and barrier placements along the river network in a topologically accurate representation of real-world systems. FIPEX users can assess both natural and anthropogenic barriers in relation to fish migration. FIPEX outputs a barrier summaries matrix for individual barriers, which is used to facilitate the calculation of the Dendritic Connectivity Index. The Dendritic Connectivity Index uses the barrier summaries in R, creating a simplified network to evaluate the effects of a number of barriers, the passability of each barrier, and the placement of each barrier on the overall connectivity of the network. From the calculated DCI, users can identify where the placement of barriers can be optimized, or what current barriers should be prioritized for restoration or removal. From this compiled information, users can then create an informative map of the greater river ecosystem to classify areas of the river network according to their degree of habitat connectivity. However, both FIPEX and the DCI can be used as standalone tools for assessing connectivity. FIPEX is an easy way to create and visualize topologically correct river networks from geospatial data. FIPEX is more flexible than previous methods of connectivity analysis, as users can alter network connections and barrier placement without a network rebuild. A user can adjust multiple variables and run a model several times without adjusting geospatial data. This flexibility within the modeled network allows users to make informed decisions on barrier mitigation projects. Within FIPEX, users can categorize network segments into user-defined classes such as lakes, rivers, or wetlands to create models that are more reflective of real-world river networks. FIPEX can be scaled to assess the impact of single barriers on one river or assess the connectivity of an entire watershed. Finally, FIPEX prepares river data to be used in the Dendritic Connectivity Index. FIPEX assesses the impact of individual barriers and outputs a barrier summaries data table to be used in the Dendritic Connectivity Index. The DCI is an R-based statistical tool that calculates barrier passability from geospatial data. To create a river network for analysis, the DCI only requires a sync point and lines representing streams. The DCI can then assess both natural and anthropogenic barriers along the network, such as waterfalls, culverts, or dams. The DCI has two variants, one that quantifies connectivity for stream residents, and one that quantifies connectivity for species that migrate to and from the ocean. The Fish Passage Extension and the Dendritic Connectivity Index offers a toolset for users to evaluate the impacts of barriers in real-world ecosystems through modeling river networks. FIPEX and the DCI allows researchers to include connectivity in habitat studies to make informed conservation decisions on development and restoration projects. FIPEX and the DCI can help to ensure project planning embodies the conservation of migrating fish species. The Fish Passage Extension and the Dendritic Connectivity Index were developed in collaboration with Memorial University of Newfoundland, Dalhousie University, Natural Sciences and Engineering Research Council, Parks Canada, and the Department of Fisheries and Oceans Canada, and Nova Scotia Power.